Great. Did you manage to grab that? Okay, what was the title then?
Efficient thin client verification of identity.
Great. Any more questions? Great. Next person, please.
Okay. Hello.
And by the way, guys, if you could stand, like, since you're like waiting for execution.
Okay. That's sort of a ad hoc table that sort of coalesced. I would say the short summary. I'm that Taj Raja, working on Lightning Networks. Where it's TMI, too much identity, and we sort of took a different view of all these things, and we're sort of like, well, identity's sort of not good. This is sort of something that we're trying to avoid in a lot of the systems that we're building, coming from Bitcoin. You want the least possible. You know, only rely on identity when you've already, you know, gone through all the other options. And you know, we already think there's too much identity. You know, there's all this tracking, all this like unique identifiers and stuff, and hopefully we can get rid of that with some of this technology. And so we sort of wrote about a spectrum of identities where you can have, you know, nothing. You have no idea what's going on, and move that to some kind of ephemeral identity, where there's either ephemeral key pairs or some kind of session cookie kind of thing, and then move stronger to a persistent identity, and then move even stronger where you're now linking these persistent cryptographic identities with some kind of legal or biological entity. And so sort of we think, you know, a best practice would be to use the weakest and least powerful identity system that can be applied to what you're trying to do. So, you know, use attribution and, you know, a set inclusion proof rather than a unique identity when possible. So, for example, you go to the taco truck and you order a chicken taco, and they say, "What's your name?" I often give a fake name. I don't know if people in this room do, but I'm like, "Yeah, I'm Fred," because they don't actually care what your name is, right? They just want a unique identifier so that when your taco's ready, they call out, "Hey, Fred," and I go get my taco. That's an ephemeral session token. And it doesn't need to be linked to. It does not need to be linked to a legal identity. So that's one aspect. Another attribution aspect is, let's say we're in the future and I've got a taco drone delivery service that's over darknet market or something. I want a inclusion proof that the FDA or the city inspector has inspected the taco production facility and that it passes code. But I don't need to know who's making the taco. Right, so I know, okay, the inspector, this is a clean place, I'm getting the taco drone delivery, but I don't know where it's from. So use attribution when it suffices rather than a unique identity. Also use ephemeral identities when they're a suffice and you don't need a persistent identity. And if you need a persistent identity, use one that's not necessarily linked to a legal or biological entity. So basically, and also have repudiation when possible. So don't sign, use Diffie-Hellman. If you can, have something where it can be deniable after by partners. And this is sort of thinking this way because we sort of thought, data is a liability, and you don't want lots of customer data, you don't want lots of user data. This can hurt them, this can hurt you. So, minimize that to the extent possible. So that's sort of what we discussed.
Next steps?
I don't know, we sort of discussed, we should have a sort of best practices or sort of, strive to work on this when making applications in the blockchain space or the space.
Questions?
I have a question.
Yes.
How does this relate to, if at all, to persistent pseudonymous?
Yeah, so that's like a fairly powerful identity, which can still be not linked to your legal identity. So, it's pretty useful. Like a lot of what Bitcoin and things like that is, okay, we don't know who it is, but we can see that there's a persistent entity here. And so if you need that, you can use that. But having an ephemeral identity which gets discarded after each use is even safer in many ways, because once you link a persistent pseudonymous identity to an actual person, you can sort of go back and figure out everything about that. So you don't have forward secrecy then. But yeah, it's complicated stuff, and this is what we're sort of arguing about, all these different aspects. But that's our perspective on it. Okay, thanks. Next person.
Hi. So my group was a little bit different. We were not one of the working groups here for the project. We were actually listening in on the Hyperledger call where IBM was presenting their identity thing. So to give the title, it would be Hyperledger, IBM's Membership Services Architecture. And really what that was about was some folks from IBM and folks who had worked on this service spent about an hour going over the architecture that they are proposing for the Hyperledger project, which is based on their membership services system. This system is a combination of centralized and decentralized services. IBM actually leans very heavily on the certificate authority, both nomenclature and structure, as a way to build this service out. It is a system that's built with the idea of both long-term identity pieces and short-term identity pieces. When you first are creating or setting up on the blockchain or connecting to the blockchain, actually this gives me a good reason to step back for a second. With Hyperledger and with IBM, one of the things they said was really when they built this proposal with the idea of private or permissioned ledgers in mind, as opposed to kind of open permissionless networks. So some of the things you'll hear me talking about here may end up being more relevant in the private case than in the public case. So a couple of the things they're doing. One is they have this idea of long-lived certs, which are called authorization certs. This basically gets generated when you're creating your account or signing on to the blockchain for the first time. And then the idea of transactional certs, where the transactional certs may have a subset of attributes in it and are to be ephemeral, only used on a single transaction. And the purpose of the transactional certs and doing it that way is really to help reduce or prevent correlation, right? So that someone who was involved in one transaction can't necessarily see the other ones that you were involved with. There were some interesting concepts that they had built in there. One of them was the idea of building something where, for the first authorization, you may be looking for a generic attribute, like this person is a licensed plumber, when someone initiates a first transaction. But when they come back, you may want to know it's that same individual coming back, not just that it's any individual plumber, right? And so there may be cases where specificity actually goes down over time in terms of who you're dealing with. They, as I said earlier, were really heavily dependent on third-party validators and kind of certificate authority structure. And a lot of that had to do with relying party risk, right? If your counterparty is taking any risk in the transaction, they may want to have somebody other than you yourself who has signed off on your attributes. I think that was a lot of the high-level pieces that came in. There was a lot of technical detail that went from there. Is there anyone from my group that thinks we missed anything major there? Christopher, anyone else? No? And they actually, they went into enough detail on this that after an hour we weren't all the way through the proposal. So there's still some more to go. Any questions for anybody? Yeah. I don't think we covered where those identities get stored at all. That was never talked about or discussed. So. Yeah. Yeah. They're going to go through the rest of their proposal on the next call, I believe, right?
Part of the reason why I felt this is relevant is that Hyperledger is an open source project. It is not a standards project. They've sort of deliberately said we're not doing protocols, we're not doing APIs, things of that nature. So I think there's some opportunity, especially in when we start talking about multiple blockchains or interoperability between blockchains, etc., that there may be some things from that world that can be standardized and be used elsewhere, or vice versa, things that can be useful from other technologies, other projects that can be an API or a standard that Hyperledger can use.
Hi, I'm Bart from Philips Blockchain Lab. We've been talking about blockchain standards in healthcare. I think in large part what we are missing from the discussion is how standards tie into existing regulation, which can sometimes be contradictory depending on the use case. So we discussed, for instance, self-sovereign technology and how that can bring great value to healthcare. On one hand, for individuals, giving them control, having better privacy measures, but also for companies like Philips, big aggregators that make money out of doing big data analysis, but also become liable for all the data they have. So if we can drive the liability to the edges, that would drive down the total cost of ownership of data for companies like Philips. And I think that will be a big driver for adoption of standards. So meetings, making some sort of business sense as well as technical sense. So we need to solve two things: the aggregation issue, which is kind of optional, and the transactional issue. But these two they need to come together because I think we need this to be bottom up, but also in regulated environments we also need it to be more top down for adoption purposes. So we need to be able to safeguard integrity of what happens for dispute resolutions, for audits. We need to allow for data aggregation in a privacy-friendly way, and preferably leaving all the data at their points of origin and not on the blockchain. So what we suggest is to break down in three standards, which are related but orthogonal to each other. On the one hand, we have blockchain and self-sovereign identity, for instance, for physicians and patients. We have standards around authorization, so private information, but also OAuth and FHIR standard, stuff like that. And we have something we call the digital postmark, basically being able to prove whatever happened in a public fashion. And I think our main conclusion was that standards need to take into account the regulatory requirements, or adoption will simply not happen. And looking at the medical space, you have this big paradox of transparency versus privacy. And I think we need use cases going forward that work together with regulators that demonstrates this functionality.
And so to sort of bring this all back again to standards, we talked about the three kinds of standards that you just mentioned. And we could also talk in terms of three kinds of technologies that these standards tie together. The technology that I would call self-sovereign mobile device, which is clearly the only place you can have a biometric, for example, and control of private keys. Self-sovereign servers, like, for instance, an authorization server in the OAuth sense, and an attribute server in general. That's the second kind of self-sovereign technology. And then the third kind of technology is what we would call reputation. Clearly, that's the part that cannot be self-sovereign, and it might be the one that both in terms of the compliance sense and in terms of the reputation sense, the blockchain is most relevant for. So these three kinds of technologies need to be tied together by these standards, by these three kinds of standards that we listed.
Any questions?
You mentioned on the authorization layer or Troika, the Auth 2. Could you just expound a little bit? What's the connection there? How would you, was it built on it or connected somehow?
The authorization component is essential for self-sovereignty in the sense that just like we want to control and have sovereignty over our private keys for non-repudiation and for all of the obvious reasons, we also want to have sovereignty over our policies. We do not want to publish our policies. We only want to publish authorizations. Or another way to think about it is we never want to have any kind of informed consent in the big data case, in the high dimensional data case that we're headed for. We only want to have flexible authorization for transactions that involve our personal data. So this layer, this OAuth, or the UMA layer to be exact, which is also a standard nowadays, is what separates our policies, which are just entirely ours and not to be shared with anybody, with the transactional parts of the system.
Any more questions? I guess this summarizes our sessions on identity. If you'd like to talk more, I'm sure we will be talking more about identity. Please feel free to do so. You know who is leading the sessions. There's the summary there on the boards as well. And we will move now to the next session.
Hi folks, we caught up some of our time, so not all of it, but some of it. So I think that we've got more of a hang on how we're going to be doing this. This is going to be the format for the remainder of the workshop. And I'd like to introduce Neha Nurullah. Neha is driving the thing on the hosting session on provenance.
Hi everyone. First of all, just real quick, does anyone have any comments on format? Is there a tweak you want to see? Is there something you think is working or isn't working? I just wanted to give an opportunity to kind of raise that. And if you don't want to do it right now, but something occurs to you, please tell us and maybe we can make a modification. Okay, just keep it in mind for later. Okay, so this is the session on provenance, which includes, there's a card up here. Okay, which includes licensing of IP, assets, sourcing of any sort. And so could the speakers who agreed to give lightning talks come up here? Thanks. Great. Yes.
Sure, that's a great idea.
Okay.
So everybody, please, I see some boxes. I'm guilty of this myself. Please dump your stuff there, and we'll reconvene in 5 minutes.
Essentially, I got interested in Bitcoin and blockchain fairly recently, simply because I came to understand that it's not only, as many call the distributed ledger, a value transfer system, it is also a memory transfer system. And when you talk about a distributed ledger technology, you are talking about a technology that captures memories of transactions and allows those memories to move through space and time. And essentially, that is something that I recognized. I recognized that as a type of record. So a ledger is a type of record traditionally. And there are a number of international standards, as I will get to. One of them is ISO 15489, the International Records Management Standard. And you'll see, this idea of memories of transactions as evidence, something that we might think of as proofs on the blockchain, is very synonymous with records as information created, received, and maintained as evidence and information by an organization or person in pursuance of legal obligations or in the transaction of business. So this is why, as an archival scientist concerned with record keeping, I am fascinated by the blockchain. So here's a claim from a company about the potential for record keeping of blockchain from Factum. I think there is someone affiliated with that Factum even here, maybe. Blockchains are archival record keepers, permanent and transparent. They are the perfect solution for an industry-wide problem of transmitting and archiving critical, accurate records. So if this is our objective, then I think that we should understand that there are a number of archival standards out there. These are just a few of the International Standards Organization standards that are relevant to record keeping. I won't go into details. I will give you these numbers and you can look them all up, but they have to do with persistent archiving of records, record keeping standard, digital record keeping standards, and so on. But what do they all say? So fundamentally, we're really talking about the requirements for proof. And if I were to summarize all those different standards and some of the basic underlying principles and theories from archival science, it would be that, first of all, the requirement is that your records be reliable. And that is the relationship of the facts in the records as representations of real-world assets or things or people, whatever you will have. They should be accurate, complete. So there should be an underlying quality. There's different aspects of reliability. There's the reliability, the truthfulness of the facts. That's historical reliability. And then there's a documentary reliability, how well the representation actually represents the real-world facts. So it's nuanced, but I'm giving you the 5-minute summary. Then there's authenticity. That talks about how much reliance we can place on establishing and preserving the identity and the integrity. So this notion of authenticity and non-repudiability, also the persistent integrity of the record from point of creation to a time thereafter. Something I'm not hearing a lot of is this concept about archival bond. It's probably something you're not familiar with, but what I do hear, at least on our table this morning, we talked a lot about not storing actual records on the blockchain, but just hashes on the blockchain and having links or mappings. So this is what we would call in archival science the archival bond, to be specific, an authenticating archival bond. And those also have to be persistent. So one of the attack vectors or weaknesses in a system could be to actually rupture that bond, the link between the hash and the originating record. And then you also need bonds between the real world thing that you are representing as a record and the hash representation. So it gets complex as graph theory comes into play there. And then of course persistence, which a number of you have mentioned already. So things like semantic persistence, representational, technological persistence. So these, some of the standards are encapsulated in these standard ISO standards that I mentioned, the Open Archival Information Systems Framework, for example. So that's an overview of some of the requirements. Risks. So the risks that I see is if we don't think about record-keeping standards, we don't make use of the principles of archival science, we risk reliability and authenticity, and also long-term utility and persistence. Obviously, we don't want to do that. We want to avoid that so that we can take advantage of the opportunities. So we're researching some of these problems. We're looking at in this Inter-Pares Trust organization. It's an international research partnership that I belong to. We have a project called Truster, where we're trying to investigate long-term preservation of trustworthiness of digitally signed, timestamped, and/or sealed digital records in various jurisdictions. That's the URL to find out more. And so basically, what I'm trying to convey here is that there is an archival science that underpins record keeping, and that because blockchain is fundamentally not only a value transfer system but a memory transfer system, that record keeping theory or archival science is highly relevant to conversations about blockchain and even some of the issues about identity and provenance that we'll be discussing today. So thanks.
So next up we have Kenji Saito from Blockchain Hub.
Hi, my name is Kenji Saito. I'm with Blockchain Hub and also with Keio University, both are based in Japan. And where I come from, it's 3 in the morning. So excuse me if I fall asleep during the slide talk. First, my background with blockchain. I'm with Blockchain Hub. So thank you for letting me be part of Blockchain Web. I'm from Blockchain Hub, and it's a startup based in Tokyo that hosts a community of blockchain developers and their potential clients, and giving the lecture series and also consultation to the industry. And my trip to this workshop is sponsored by Blockchain Hub, and by mentioning that, my mission is accomplished. And I can move to a more important topic of digital assets and the missing link. And here's my understanding of the blockchain technology. The 4 layers of independent technology. From the bottom, it's a ledger structure, distributed timestamp, consensus mechanism, and application logic. And by these interworking of these layers, blockchain can give total controls of the assets to the ends, and that materializes the end-to-end philosophy of the internet, which I think is a great thing, although I've been criticizing the other aspects of the blockchain. But the intention is, I think, great, but there is a missing link. It would be nice if this blockchain can manage the digital representation of physical assets, like real estate. Actually, I've been working with a real estate escrow service company in Japan to work on the proof of concept service of the real estate trading based on blockchain. And in order for this service to be usable, there must be some official and trustable connection between the digital asset and on the blockchain and the physical entity. So there's a missing link between the blockchain and the physical or logical entities that must be trusted, right, and official, that cannot be solved by the technology alone. And also, we cannot, since this is a workshop on the web and the blockchain, we cannot ignore the web technology, although I'm not really particularly fond of web technology in terms of its architecture. But in fact, the real estate trading service I just mentioned is using the web technology. It's a web service. So the first thing we have to realize is that the web element on the web page is associated with a digital asset on the blockchain. If that can be done, which can be done in a technological way, then we have trusted web elements backed by blockchains, which is useful for the services like real estate trading, but also in any web page, we can now have a system of trusted management of the elements, their history, and the identities, and so on. And then the logical elements on the, as the web elements must be mapped to physical entities in case of real estate and things. And that cannot be solved by technology alone, so it's a social technological, or technopolitical, whatever you may call it. And that technology can assist that. For example, by describing the physical entities. Like in case of real estates, if we can describe the real estate like by this address and the size and the shape, and then we can incorporate. We can do services like separating the one real estate into two, and the trade them separately, and still have a consistent mapping between the physical entities and the blockchain's logical assets. And in fact, W3C has been working on the ontology on the web, so maybe that's useful, or maybe we can use a taxonomy, which is a distributed and autonomous approach to achieve a similar thing, or maybe in combination of the both. So the question here, one question is how we can map the digital assets and the logical entity on the web, which is a new question we must work on. And here's another question, which is existing mechanisms that connect the real world and the web sufficient as the foundation for this? And this may be the question we can ask in this session. Thank you very much.
Thank you. Next up, we have Chris Zay from Monograph.
Okay, can you guys hear me? So I'm going to talk to you guys about rights system. So a system that allows us to break down and trade rights, like the right to a movie, or the rights to make money off a character. My son is 2, of the things that Disney makes when I buy all kinds of random stuff, right? So the rights are really important in the media world, not only for the physical asset, the song, the video, but also for other type of intellectual property. So Monograph is probably most known as the media rights blockchain-ish company. But what I want to talk to you about is some very specific aspects of what we discovered about how to model rights, but why is it important? Kind of extending and maybe contradicting the point that Daniel was making further, that the rights is not just a contract you can hash and put in a blockchain with an identity mapped to it, but not have to necessarily have any record about the rights of the blockchain. Because in a lot of cases, you're trading the rights, I'm selling the rights, I'm lending the rights to you. So maybe the digital scarcity aspects of the blockchain and Bitcoin blockchain specifically is all Monograph use, but it can be extensible, could be a good way to think about whether other types of digital assets or physical assets without archival bonds or linkages can be actually represented, actually using the graph of spends and tokens, not just saying, hey, I have a contract, let me hash it, but actually trade some sort of tokens on the blockchain to reflect the reality of the ownership of those assets. So I'm going to go deep dive into this, and I'm the co-founder and CTO, and I'm also here because Monica is a W3C member, and I will talk about some of the work we're doing on the semantics aspects of this at the W3C. So let me just go and quickly go through a story, which is exactly, it starts here, which is an artist created work. So you have the source file, you created this media. You have it on your computer, you have it somewhere. What you get is that you get automatic copyright. You can certainly register copyright in your jurisdiction, but you get some
circle C thing, but that's nothing to do with blockchain until you say, let me hash this work, hash a contract, this work, a title, something that I'm claiming. I'm going to register that title in the blockchain, and that creates a record in the blockchain reflecting this media you just created. But that's not right. That's just the thing itself. But a lot of times what you're really thinking about is a picture of a waterfall and license it like a stock image or something like that. What I'm really creating is another right, which is an offer to license this one to other people, and whoever owns this license therefore has a usage right. So I'm creating possibly two more things, whether they're tokens or they're records within a document inside here or there. And then what I can do when Bob comes along and say, hey, I want to buy this license,
So this would be a royalty-free license, and with the possession of that rights, I can download the source file. So you can imagine the source file being hosted somewhere, decentralized or centralized. You've got a contract language to express and a token exchange of the rights and the contract itself. And then obviously payments needs to be settled. These are all the things that needs to happen for a simple, buying stock image to do it. The blockchain currently doesn't do this very well, decentralized, but if you mix together centralized, decentralized, it's a chance. But it gets a little more complicated than that. But if you're buying a fine arts work, not only are you giving a usage right to display this work, you're also giving a resale right. So that when someone buys it, that person retains the token to not only use it, but also to retain the token to resell that. So if someone comes in the future, so I pay that person for the work, but if I want to resell that right, based on the fact that I possess a usage right, I can then go to Charlie, the third person, and then say, I possessing a usage right, allow me to transfer this title to the third person, and therefore that person would get paid, and that payment could actually, if it's modeled certainly with the business logic, require some sort of a commission for the original owner. This is related to the 70s of the artist resale right agreement, when artists would gain from the rise of value of the work in secondary sale. The one that you see here on the title version 1, 2, and 3 is the provenance of the work, which is the record of history of ownership of that work. But that is not the entire equation. There's all the other rights issue associated with it, and most of the money that comes beyond fine arts actually becomes much more important in those other kind of secondary rights or derivative rights use. Consignment is a complicated thing because you're saying, I want to give someone permission to sell this work for me. And then what I'm basically selling or trading temporarily usually is a publicity right and the ability to sign a contract of agency so that that person can represent me legally and also provably legally in a verifiable way. And then that person, in this case Delta Gallery or the gallerist, can now resell this work. And then when that work is sold, the rights, the usage right and resale right does not pass through that agency, but go directly to the end buyer, in this case, Charles. And then when that happens, the payment is split. In fine arts, unfortunately, is 50-50. So as you can see, as this stuff gets more complicated, where there's a commission of work, there's a whole lot of relationship and intersection here of usage right, receivership right. One of the most interesting thing about receivership right is that you can now, let's say I sold some work, commission of work, I can actually trade the receivership right, which is a royalty like a Bolivar, the revenue received from this work being commercially useful, and I can sell that independently of the title of the work. So I can own the work but not own the revenue that comes from it because I mortgaged it or I sold it to another party. And that allows financial services to participate in the rights equation, which they already do. But by providing these primitives and thinking about how this maps to the rights expression, we can allow this kind of ongoing payment to go to the right place and allow that to actually happen there. So I'm going to just jump to the conclusion. The conclusion is that this is a complex field where just on the constellation of rights that we see the contract documents and clauses, which are the tradable tokens of having rights to do certain things, the media themselves, and then the payments associated with it, it's an extremely complex thing if we were to actually model what actually goes on today in films and movies and TV shows that have a constellation of rights across multiple works. And I think getting this right requires a standardization effort. Semantically, Monograph has supported and participated in the W3C Permissions and Obligation Expression Working Group, which is really thinking about the contracts, language, and the way that express what is actually being traded. But as far as the mechanism of what rights are actually on-chain, what are hashed on-chain, can we use other blockchain permission ledger between industry trade groups? Those are all the things that I think is going to be a very important discussion going forward.
Thank you, Chris. Next up, we have Dennis Nazaroff from MediaChain.
Hi everyone, it's really great to be here. My name is Dennis Nazaroff, and I work on a project called MediaChain. So blockchains are really interesting in a way to apply scarcity to creative works, but the other side of media distribution and scale, and the internet has been called the most efficient copy machine, and the history of media sharing on the internet has been that it's been really, really easy to reproduce media and for tons and tons of people to be able to consume it, starting from Napster to file locker days to the BitTorrent days. And what's been really difficult, while so many people can consume information, it's been really difficult to preserve information about the creator and to have the creator's identity to live with works as they are widely shared. So when media is shared today, attribution is easily lost, and any context and history about creative works is not preserved. So we see this daily on platforms like Twitter. This is a popular social media account called History and Pics that is known for aggregating historical images and just reposting them and getting tons and tons of retweets and tons of likes. And the problem today is that when someone that follows this account presses like, that gratitude goes to the account that is aggregating the information, not the author. So we don't know, other than this kind of vague caption, we don't know who the author is, we don't know what the story behind this image is, we have no way of contacting the creator, we have no way of telling the creator that we appreciate your work, we have no way to learn more of their work. So we're really approaching this from an information problem rather than a scarcity or payments problem. So what MediaChain approaches is from a technological perspective is that there's two insights, and one is taking a decentralized database and combining it with content technology. So a decentralized database allows anyone to participate. There's no central point of control or failure, and every node joins a single logical data space. And this is built on top of IDFS. We'll hear more about IDFS later today. And on the other side is Content ID. So Content ID allows us, if we have two instances of the same work, on the top you see the Mona Lisa that's slightly greener in the JPEG format, and on the bottom slightly yellower in a PNG format. So if we take a cryptographic hash, these files would get completely different output. It would seem as completely different files. But using image recognition, we can resolve these two instances that to a human, it's obvious that they represent the same work, and we could give them one identifier. What this allows us to do is, one, to collaboratively talk about the same work. So if two participants are making a statement about the same concept, for example, MoMA says that this painting is by Pablo Picasso, while the Tate says the title is Piro, we can use content ID technology to unite these two statements under one identifier. And on the other end, on the consumer end, content ID allows us to search with the content itself. So how many of you have used Google reverse image search before? How about Shazam to identify a song? So with content ID, if you remember the history and pics example of that anonymous image, in the media chain system, you can use the instance of the image itself as a way to query into the open database. And here we would return this aggregate statement combined from information from the MoMA and Tate to get metadata about this one. And now I'm going to talk about more depth about the data structure behind it. So kind of the fundamental unit of the system is a statement that a participant makes. So here you see that the title, the author, and the year has been signed by MoMA about this artwork. And metadata in the system is derived from existing metadata that already exists in translators. And here we're dealing with the schema problem. And as the W3C obviously knows that having large amount of people to agree on a data standard is a very complicated, arduous process. We're saying that let's not invent a new schema that requires everyone to conform to it. Let's create translators that allow people to retain their metadata format in an undestructive way and to translate certain fields into the system so you can index by properties such as the artist or the title. And each statement is cryptographically signed with the participant's key pair. And these statements about a work are tied together in a chain. So here is a statement by Tate at the top, a statement by MoMA at the bottom, and we can, at read time, combine them into this composite view describing that artwork. And if there is a bad statement, so in this example, Donald Trump has contributed something completely unrelated, at read time, you can have basically waitlists for parties in the system that you trust. You can discard. So basically, the openness of the system allows data to create a network effect where the more data is in the system, the more valuable it is. And some applications of this are attribution and analytics. So creators can, we can know who the creator is, and if creators work with you somewhere across the internet, they can have basically a ping back saying this image was used here. An open system allows anyone to make statements, so there's completely tremendous implications for annotation and, for example, recording where a work is being used online, and also we can surface metadata conflicts. So today, data that is in silos that don't speak to each other or aren't aware of each other, because the data lives in one logical space, we can see which institutions have conflicting statements. So we can search across data sets, we get global IDs, data collaboration is enabled because the system is completely open. Everything is hashed and content addressed. Attribution for creators and institutions is automatic. And in terms of progress in the project, over 2 million creative works have been contributed by some reputable organizations. Last week we recorded our first public demo of contributing and querying the system, and in the next week we're launching a public testnet. So it's a completely open source project, and we love any help, any data that anyone is interested in contributing. We love that. And we're really interested, as Media Chain being sort of the foundation for a new generation of applications which automate attribution, which automatically link back to creators, and also give developers use a media library where they can have access to content on the creator's terms. And here are where you can learn more about the project. Thank you very much.
Thanks. Okay, great. So I think this is our last talk, and this is Trent from Big Chain DB.
That's why standards are so great. There's so many to choose from.
Hi guys, I'm Trent, and this is actually on behalf of Koala IP Working Group, and I'll be talking about a protocol for IP that this working group has been developing. I'm from BigTDB, which is a for-profit company, as well as IPDB, which is a non-profit that has a public blockchain database. So, a bit of background, I started working full-time in the blockchain space about 3 years ago doing Ascribe, which was focusing on digital art on the blockchain, and there was a whole bunch of sub-problems to solve back then, and as we generalized from Ascribe, which was just starting with digital art, as we generalized, we asked ourselves, how else do we serve other types of IP? And you know, as we tried more and more things, we realized that it's really useful to have a general licensing framework. Some of the specs include, it should be really easy to use by all the different participants, whether they're developers, rights holders, copyright societies. It should be extensible, feature-proof. It should have immutability and tamper resistance, so a couple nice characteristics of blockchains. It really should be agnostic of blockchains, and it should be free, as in free and open source software for everyone to read and use. So that's the goals of this framework. History of Koala, it actually started with a workshop at MIT/Harvard a couple years ago, 2.5, I think. And these workshops happen 3 or 4 times a year. And starting last fall, there was a working group for IP that emerged from it. And some of the collaborators in this included people from Koala itself, IPFS, Ujo, Consensus, Mycelia, ourselves, Scenario, MediaChain, and more, and relations with Copyright Hub, Open Music, and more. So, and you know, these individuals alone just represent people that are working, building on top of the Ethereum network, IPFS, IPDB, and more. And when we were doing this, one of the major goals we had is simply to invent as little as possible and to reuse whatever well-considered building blocks are already out there. So there's one building block that is maybe the centerpiece of this, and that's something called the LCC framework. And it is the culmination of a lot of work. If you've ever used SoundCloud or YouTube or listened to a song in Universal Music or anything, all of those are following a standard from the music space called VDEC, which goes back a long time. If you're using Getty Images or any other standards for photos, it comes down to a standard called Plus. It turns out that the people who developed Plus and some others, collaborators, they got together with 90 partner organizations and they developed something that generalizes all of this, and it's called LCC, the Linked Content Coalition. And an organization called Copyright Hub basically drove this over the last several years. So that's what LCC is. I'll talk a bit more about it. Also, there's other standards out there that have been that are valuable as building blocks. One of them is linked data itself, and in particular, the linked data format JSON is one of them is JSON LD. There's also something called IPLD, which is very, very useful for integrity. Maybe one I'll talk about it later with IPFS. And finally, interledger protocol, which allows these data blobs to actually live on many ledgers at once and to transfer from one to the next to the next. So I'll talk a bit about these different building blocks in the next few slides. So LCC, in general, like I mentioned, it generalizes widely used IP standards, including DDEX and more. It has a bunch of different documentation, including 10 targets for a rights network. So if you're ever going to be developing standards or a rights network, this is a really good starting point. Principles, and the real meat is the entity model and the rights reference model. And to give you a feel of what this looks like, this is the rights reference model. It has 7 entities within it. And these are entities like party, creation, place, and so on, and how they relate to each other, including the nodes and edges. So this is something that's extremely well defined and a lot of documentation, actually too much documentation. But it's out there, and it's been well thought out. IPLD is basically a way to take a JSON object and it's opinionated about how you hash it, so that you can have Merkle hashes on top, linking from one object to the next to the next. And then you can also paths to this. And these objects, they are native IPFS, but they can also live in other networks, blockchains, etc. So this is actually standard in IPDB as well, for example. and I'll just skip this slide. Of course, there's RDOF. We all know about this, so I can probably skip that slide too. JSON-LD is one way to serialize RDF in JSON. It's emerged as probably the most popular standard for linked data in JSON. And there's also, if you look around, you might ask, okay, well, if you're using linked data, what exact definitions of the data are you going to use? And schema.org is one that has emerged as a big one, and it's used by Google and Facebook and many others. And there's been tons of work to define this very, very refined. So there's actually very good definitions for a person, an organization, a creative work, a music composition, a book, a movie, and more. And so we don't have to go and reinvent this wheel either. We can just re-leverage that. For connecting different blockchains and ledgers, there's something called the Interledger Protocol, which is actually a W3C community group. And there's more than 100 organizations that are participating in this. It was initially released last fall. And so it's really good for connecting blockchains and sort of think of it as like routers in the internet. It also has something called crypto conditions, which is really nice building blocks for crypto primitives. So you get things like multi-sig and escrow, but it doesn't go as far as loop recursion. So it's a very useful tool for basically connecting these chains when you want to transfer value from one network to the next. So overall, what the Koala IP protocol is about is bringing all these things together. So it's got this minimum viable set of data for IP licensing, and that's basically these RDF schema definitions using JSON-LD, as well as a free and open messaging protocol for licensed transactions. So LCC is really the part of this, but then also we can leverage interledger activity. So with this, basically what we've done is taken this and come up with very specific examples for these sorts of things. So here's an example of a place. And notice in the top where it says type, it's got a hash under the RDF schema of place. And this is a hash using the IP spec. And then the geolocation, the name, etc. So that's a place in the Koala IP spec. You can also have a party, and of course this relates to identity. You can have a creation, so this is actually an RDF schema for creation. And you can have creation in a couple ways, a digital or a physical manifestation. And manifestation itself is something that is defined quite well in schema.org. Here's the physical version. You can also have rights, so this is something that has been defined as well. And rights assignments. And rights assignments is actually kind of special because it needs to be transferred from identity A to identity B. And this is where Interledger Protocol comes in very handy. So it basically, what you do is you follow the Interledger Protocol, and from that you get provenance of the assets going from person A to person B, these different rights that get assigned. And that you can also do things like escrow, which is kind of cool, just in the blocks. It also supports the idea of insertions. So a person A can say, hey, this person's claim here. Okay, this person's here claim is no, that's an incorrect claim, or yes, that is a correct claim. So to wrap up, to summarize, the goal here was a licensing framework for digital assets, using the previous building blocks as much as possible. And so this protocol is a data set for IP licensing, as well as a messaging protocol around it. And there is a community that's coalescing around this, and it's going into these different networks already, just from the people involved. And of course, one of the hopes is that this can reconcile well with a lot of work in W3C. So that's the Koala IP protocol. Thank you.
Thank you, Trent. Okay, so we're gonna change up the format a tiny amount. So you just heard 5 talks, so that will be roughly 5 tables. And we'd like to gather. Would anyone else like to lead a table? We're gonna have people volunteer to lead tables, and we're gonna take a 5-minute break and kind of figure stuff out. And then when we come back, we'll do the actual tables. So would anyone else like to volunteer to lead a table in this space? Sure. So the 5 of you who just went, if you wouldn't mind, sort of saying your 3-word summaries as we kind of get things together.
And also the more tables, probably the better. The smaller groups that can discuss things, probably the better. So it would be good for you to suggest a topic. So who was
Victoria?
So the theme or the table that I could lead how archival science and archival principles and standards could be applied to the blockchain. I'm also interested in the issue that Kenji brought up, which is the whole linking issue.
I'll be talking, I think, in my group about IP protocols, and I think probably just to differentiate, then you'll probably focus on the specifics of rights assignment. And with Dennis, I'm just going to put words in your mouth just because the Corolla IP protocol is actually quite general enough, and as a subset you can have very detailed rights assignment, as well as you can, as a subset there's attribution and not attribution, rich metadata, and so there's much of that. So I'll talk about the higher level, sort of the value transfer aspect, and sort of the IP protocol technology structure.
I want to talk about use cases, just media rights use cases, getting artists paid, all this kind of stuff. So if you want to talk kind of not about the protocol and stuff like that, just like what are the ways that blockchain and blockchain-related technology can help get artists paid.
I want to talk about the non-financial aspects. So basically linking media we find existing places today directly to the creator for the content side. So automating attribution and descriptive metadata.
Linkage with physical entities.
Anybody else?
We're gonna have 5 tables. It's gonna be pretty big. Anybody else?
I think one suggestion, a lot of us covered intellectual property, but that's really only one aspect of provenance. I guess you're going to talk about linking to physical, but there's a whole bunch of other really interesting subtopics in physical, so I might encourage some of you maybe to talk about that. You know, like diamonds in the blockchain, used running shoes in the blockchain, that sort of thing. So that's one idea.
There's also potential for Internet of Things kind of related types of stuff.
Guri?
Yeah, I'm looking at you, Guri. Would you like to lead a table?
Why don't you lead a table, Guri? So I'll stand in for Guri. Now, come on. So you're going to be talking about IoT.
I'm going to be doing a lightning talk tomorrow on some stuff. Just bring drinks. Basically, it's around using blockchain with IoT as an application. There's some work that's been done, some papers that have been put out, also some prototypes that have been built. I think a lot of work that needs to be done. So I think we can have a discussion if you are close to the IoT space, or anyone else who wants to come.
I think we have one more volunteer.
Now, this is a problem that I'm looking at in the case of the supply chain movement, or really the trade finance or goods movement. Does that fall under the Koala IP, or should we consider it separately? Should we take that in Koala IP?
Well, is it meaning? Could it be because he's got such a broad topic? Could it be meaningful to have 2 different topic tables?
Yeah, I'd like
I'm hearing
somebody
yes.
else to take them on.
All right.
But I want to propose
Yeah,
that.
so-
I would like to be a part of that.
So if you have, even if you don't want to lead a discussion, but you have a question that you feel in Providence hasn't been addressed by these things, if you have a question, that's also good, because that might be a topic table.
I'd like to maybe a quick hand poll on things. So there's a legal, so some of this relies on proof of existence. It's kind of an underlying primitive that is required for these types of things. And I know that Wayne and Manu are working on some of that type of stuff. But there's the legal side of the question. So, maybe Daza, wherever you are, are there other people that are interested in sort of things like New Hampshire just made a law that allowed records that are put on the blockchain through proof of existence type things are now legally records in that one state. So you don't have to go through extra stuff in court to basically say your thing was. So is there an interest in the intersection of proof of existence and law? And Daza, are you? Okay.
So not necessarily to lead a table, because I might need to step out and do some work. But one question is of ownership of data on the web. So, like, really actually W3C stuff on web browser, and what happens when we go online and we have all of our like identity and the stuff, our own data that we share with the web, and how can blockchain help to support solving that problem, tracking how we share data online.
And then finally,
just another kind of big question and area of research is reputation in these systems. So if an open system allows anyone to make a statement claiming ownership or something, or stating a fact about a work, how can you layer trust and reputation in tokens into a system? I don't know if anyone wants to.
and finally, if none of this interests you, this isn't a topic, you're not interested in the provenance aspect, but you have something else that you think other people might be interested in, we have space. Anybody? Okay, so we're going to be able to divide up into these groups. We're going
to take a very quick 5-minute break and then come back and divide up into groups.
Don't go, Chris, don't go anywhere. We're deciding what the topics are. I had go get a piece of paper, come back, or a laptop, or whatever you need. Okay, guys. Okay, let's metadata. Is there another one of these that you Alright, so we've got one table that's combined, so we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7 tables. Yeah. It's too big. I would the sheet. Seven's fine. Yeah, that's fine. Yep. Okay, guys. I'm gonna think I. So that's 20 minutes of discussion, 10 minutes of summarizing, like of refining. 20 minutes. Yeah, sorry. 20 minutes of discussion, 10 minutes of refining. And then I'm sorry, guys. We're getting ready to. Are you okay now? I know. I figured we'd work through the break. And we'll do, yeah.
Attention! Hello, everybody. Quiet down, please. Hello. Neha.
Hi everyone. So real quick, we're gonna start with these tables, okay? I'll go over it really fast. So right here we have physical assets in the real world and bonding. Okay. Here we have media, like real media use cases, music in particular. I forgot what yours is. IP protocols over here. Attribution and metadata that are not payment related. Supply chain, law, and then I don't know where Guri went, but he is doing Internet of Things. So did everyone get that? Follow the person that you're interested in. And we're going to do this for half an hour. The first 20 minutes are going to be discussion. The last 10 minutes will be kind of reviewing in your small groups, and then we'll come back and share.
Yeah. I don't think everybody, here's what we're going to do. We're going to spend about 20 minutes, was it? About 20 minutes talking about the topics, 10 minutes wrapping up, making sure we have the summaries, and then we're going to spend another 20 minutes summarizing everything. So 20 minutes, 10 minutes to wrap up, and then 20 minutes to discuss. Okay? So everybody should find a facilitator, somebody who has one of these. If you don't have one of these, come find me. And a scribe that's going to scribe back, that's going to report back. Who would like to be the scribe for us? Yeah, sure. In general, we just talk, yeah, I mean, it's sort of IP at the lower level as opposed to the big use cases is more of a technical. Okay. Have a seat, guys. Who would like to be the scribe? I scribe. Awesome, cool. Yeah, so we have 20 minutes to just discuss with an overall goal of really give us the correct goal. So I think maybe let's just have a conversation, right? And also, like, so how about this? How about we go around and I do an intro, and then after that, we have an intro as well as conversation topics that we want to cover. And then from that, we will go into topics. Sorry to bother you folks. Somebody is missing a lightning to USB adapter. If you picked up a lightning to USB adapter, probably somewhere in that area, please check that you got the right one and come find me if you think you might have somebody else's. Thank you.